disclaimer. Rest of the talk will be not like this. So there will be some code slides on the screen, and we will do some basic stuff. But before doing that, who knows about DPDK? I also mentioned a few times. Okay, thank you. And is there anybody already writing DPDK code? Okay, you guys will board a lot, but sorry. So I think it's worth to make some little introduction about DPDK. DPDK Data Plane Development Kit is first an open source project. It's an NFV component, and it supports multi-render NIC, and it runs on multiple architecture. And it solves one problem, mainly. That's the problem. The below is packet sizes, and for different speeds, 10 gigabit, 40, and 100. It requires a number of packets to hit line rate. If you talk about small packets, 64 bytes, the amount of packets is a lot to hit the line rate. So there's a little calculation below there for 64 bytes. It is for 4G network. Number of packets, almost 60 million. So in each 16 milliseconds, you have a new packet. So if you are doing forwarding or doing something, you need to handle that packet in that time frame. And if you have a 2 gigahertz CPU, that means only 33 cycles. So that's too less. And on the graph, there is some nodes. For example, if you are hitting L3 cache, you are still in cache, but last level cache, it takes something 40 cycles. And if you CPU miss the cache and goes to memory, it is around 17 nanoseconds. So if you cache miss, your CPU going to memory and fetching the data, you already lost a bunch of packets. So you cannot make line rate. So that's the DPDK, that's what DPDK targets. With DPDK, you can have line rate performance. So how it is done is based on some software concepts, benefiting architectures better. So it is not a regular software, mostly lower level. And I won't read all of them, but these two pages are basically what DPDK does. There is nothing new here, but all combined together to achieve this one. And I won't spend much time on this. Overall, DPDK is a framework, so it is a set of libraries. And these blocks show different part of libraries. So what we will write. It will be a very simple application. So DPDK is port-based, manage NICs in a port manner. So there will be 2 ports, a packet traffic, a traffic generator, which we won't be able to see right now, but see in the slides. Will forward between 2 ports. That's all. Here, with perhaps before end of this presentation at least, so perhaps in 20 minutes, with 100-ish line of code, we will able to hit line rate packet forwarding. So I think that will be amazing. Before DPDK starts, it requires some environments, initialization setups. I won't spend time here to describe them, but very quickly, it uses HugeBase, so HugeBase needs to be set up. Also, DPDK needs not kernel drivers, but URL-based drivers to be manage the network card. So this is a tool by DPDK Dev Client, and it shows here two NIC already driven by URL driver. So this is basic makefile, and this is all we use as a makefile because DPDK make system supports external applications. Just include them and set our target and source file. As you can see here, all we need to do is set RT SDK variable. So these are just sample to show what we are doing. I will not talk now. We will start with this one. From this one to a forwarding application, step by step. In this kind of screen, left side is the code we are adding in a unified diff format, and right side is what happens when we run that code. So we will do change and we will see the output. And we will start with an API call. This is the most basic and most perhaps important one, AEL initialization. AEL is environment abstraction layer, and it does all heavy work. It initializes hardware. It's on top of hardware. So what it does, initialize memory, initialize cores, and initialize NICs. First, scans the system for network cards, then finds them, probes them through the user space Ethernet drivers. It gets arguments, program arguments. You can pass them to AEL. Normally this simple application, you just pass them directly, but in a different application, you want to use some of them for application itself and pass the other to the AEL. And when we run the application, won't do anything useful in this stage, but as you can see, it found some devices. Now your application is aware of some PCI network devices. But right now we are not doing anything with them. Next stage, although all network interfaces probed, you don't know anything about them yet in our application. So there are a set of APIs that helps us learn more about what we have. So one of them, simple one is it easy to see the code from there? Okay, that's a problem, but it looks like font size better, not the back, because there was a complaint from the side. Okay, I will try to explain more. This one, RT/ETH dev count. It will give the number of the Ethernet ports right now your applications know about. And the simple application requires at least 2 should be. And it will be times of 2s because we will do forwarding between them. Again, when we run it, there is nothing special there. This is just to show DPDK as well as has some APIs to control the Ethernet device. It also has some set of helper functions like this RT loop one, and there are many. If you are developing a DPDK application, you may go discover them and use them. And the next thing, that's also something important and perhaps can be new. RT packet mbuff pull crate. So to describe what it is, I need to describe what mempool concept is in DPDK. Since DPDK manages the memory, indeed it has to manage the memory to see the numbers you have seen, because we don't want any TLB miss. So we cannot rely on, we cannot directly use operating system memory allocation APIs. So that's why DPDK use huge base to reduce the TLB miss, first case. And during AEL initialization, it does a few things. First, finds the continuous memory, Then does our mem zones, creates memory segments, and on top of this there is a mempool concept, which is indeed fixed size of memory managed by a ring. So instead of really deallocating code, you are getting some memory information from that ring and putting it back. All is fixed size. And this is a specialized version of it for packet mbuf. And again, mbuf is like Linux skbuf or FreeBSD mbuf, a data structure, but for DPDK it's both metadata and data, a data structure to point a network packet. So when your network card receives something and that's stored to memory, that's mbuf is your reference to point them. So we are creating here a set of mbufs. We need to do this, and we need to provide this information to the user space driver to manage. So we are mostly doing here memory management part, but with a simple API. We have some amount of mempool created here. So keep going. Next thing is managing the network cards. Okay, we have some handles for them, so we can access their driver, but we need to do a few things. This is just preparation for port installation. The main thing will go here, nothing here right now. And we start doing it. First thing we need to do, this is a mandatory step, configure, this may not be a mandatory step, thanks Thomas, to configure the Ethernet device. It is RT Ethernet configure. I will just switch here to browser. To show our API documentation is already online. If you are doing something, you can find it. And for example, that, okay, it got configure port ID, RxQs, TXQs, and a configuration string which has this stuff. There are different Rx mode, TX mode configurations. Here in this sample, it does nothing, but always you can go and refer to API documentation. This application uses only one queue for the NIC, but we may use multiple queues nowadays. NIC supports multiple queues. And are we familiar why we want to use multiple queues, for example? Anybody who knows why we want to use multiple queues? Again, please. For performance, because in DPDK, each queue is a memory location. NIC puts its data into queues, and we are using a core to process that data. Again, we are very limited for time. So if you want to process more, what we can do is put data into multiple memory locations and use different physical CPU cores to process them. So we parallelize them. But how can we put network data into multiple queues using multiple, configuring our network to support multiple queues? Traffic can be directed to different queues with different ways, like RSS or any flow directed methods. And you can use multiple cores to process them and have better performance. Right now, this one is only single one queue. Next thing, for each queue, we are configuring Rx and TX queues. For Rx, we need to also provide membuf pool so that driver can use that one. Also, a number of the rings can be configured here. Number of the rings is the size of the memory that NIC used to put the packets in, we can say. Also, in most of APIs in DPDK gets socket ID as argument. If you are in a NUMA system, if you have multiple sockets, that matters which socket you are allocating your memory from and which cores you are using for processing. As we talked in the beginning, just to stress, DPDK is mostly about performance. So that's why we are in that level to say which CPU to use for which kind of queue, which queue. We configured RX and TX queues. Next thing is simple, start the port. So these are what we use for port initialization. Configure it, configure RxTX, and start the port. Nothing new when we run the application, but okay, I can see some new argument. That is -w. Since we pass all arguments to AEL, AEL already supports a bunch of arguments. One of them is -w, which whitelists the PCI devices. So it seems my system has many devices, but I don't want DPDK application to use all of them. So that's the way of saying use only this and this. So there's a whitelist, blacklist already supported there. Next step, we are enabling promiscuous mode of the NIC. So that's mainly to show there are a set of APIs that you can use to configure network cards. This is just sample, but we have lots of them. And third step, we will configure the cores, because DPDK also can manage the cores, again, for the performance. This piece of code doesn't do anything special right now. There is the API, RT, AEL, MP remote launch, and this is the skip master. So it will run this application for each course except the master. The master is the first core that DPDK knows, and by default is 0. And if you don't give any parameter to DPDK, it will use whole cores in your system. If you are using a 32-core system, so DPDK will use all of them, and you can set which core do what. AEL, MP, wait our core will wait for them to finish. And in this step, hard-codedly sets which core to use, which is forwarding core 1. So in this loop, if forwarding core is running, it will do endless loop. The rest will just print and exit. So we have another set of APIs to manage the cores. And in the sample, for example, instead of saying application use all cores, --l core parameter says DPDK application only use these cores. And in our example, it is 0 and 2. And since none of them are forwarding core, application just exit. And if we say application, please use cores 0 and 1, 1 will be in endless loop, so we will have to Control-C to break the application. So this gives flexibility to use cores. And next thing, we will start now receiving packages. And it is mainly done by RT, ATH, RX burst. DPDK use burst receive and transmit because you cannot get that numbers with getting or transmitting packets one by one. So burst is one of the methods mentioned and used. So we are getting burst amount of buffers, and if we are not getting, for this sample we are not doing anything, so we are freeing all of them. You have to free all of them. These MBUFs are coming from the mempool we allocated, so it's a limited resource. If you don't free them, you will stop. Functionally, things starts. We are transmitting packets to the other port. There's a basic logic here. This one, and mainly provided by here. So the received mBufs transmit to other port. This thing, I think a little more than 100 lines. Now, not very functional, but can do forwarding between two ports in a 10 gigabit line rate at least. Another just small feature, just to show how we can run. This application will swap MAC addresses between send and received packages. This is just preparation. And this is how it is done. The API RT packet mBuf, M2D mBuf to data. This gets the data part of the mBuf. So this is the actual data that network packet contains, and we know it's an Ethernet frame, casting direct to Ethernet and swapping the MAC addresses. So this will cause performance drop a little. Still, most probably it will be line rate, but since you are reading a new data and it is not in cache line, so it needs to be go and grab from the memory to the cache. So this will be lower performance. These are just for adding a few features. We didn't check if link is up or down in the sample application. Here the API RT link get helps us get this information. Normally, DPDK DPDK normally use poll mode drivers. So as core goes and continuously polls the queue if there is any packets or not, instead of using interrupts again to hit that performance numbers. But there's an option to use interrupts, and for link status it is possible to use link status interrupts too. Adding a signal handler, there's nothing specific to DPDK here. We will use it just to print status. This is how we get the stats, RT/ETH stats gets. There are two sets of stats in DPDK, extended statistics, which Polmo driver provides driver-specific, link-specific stats, and this is the generic one. Generic one supported by all drivers, and it will print very basically. Here we can see number of the packets received, transmitted, and dropped. That's all I have. There are references, and in DPDK repository, there is a sample application folder which has from this level to very high level, almost production level applications. If you're interested in writing some DPDK applications, that's a useful resource, and there are many applications there. In IRC, there are always some people, if you want to ask. There are a bunch of applications already benefiting from DPDK. These are just the ones I remember. I'm sure there are more. Thank you very much. We have 5 more minutes if you have any questions. Almost 5. Yes?
Is there any other libraries for other languages available?
Again, please.
Is there any more libraries available that are in other languages? Or do you guys provide anything that you
Is there any other libraries available, is the question? Oh, no, it's all C. And it has to be C because it is so low level in some parts.
The library, right?
Okay, in a higher level interface, no, right now it is only C. Yes. How big is the library? In big, in wattmans, the binary size, a few megabytes, that's not huge. Overall, it's not a very big library. It's reasonable one, I think. Okay. Thank you very much, everyone.